Hey, Vlad here from AvantStay.com. Welcome to another video. Now that the ZEO series is over, I finally get the chance to make the video about my second most requested topic, which is SBT. Let's get right to it. Real quick, yeah, you. Would you like to work with me? Because AvantStay, my full-time client, just became the very first sponsor on this channel. We're in the hospitality business, providing guests with full experiences in our homes. We're growing like crazy, and we're a fully, and I mean fully, remote team. We have a 100% functional Scala code base, a modern stack with the usual suspects like GraphQL, Kafka, Kubernetes, AWS, and GraalVM, and we're dying to jump to Scala 3 as soon as possible. If I piqued your interest, shoot an email to jobs@avantstay.com or check out the link in the description of the video, and then maybe this monologue will become a dialogue, if you know what I mean. Enjoy the video. First things first, this is neither going to be a full-blown in-detail tutorial about SBT, nor is it going to be a very long series. SBT can be very complicated, and many of you have asked me to make a video about it, and so here we are. So for now, it's going to be just this one video. Now, I already have a couple of SBT videos on my channel. However, in them, even though I explained an occasional thing here and there, most of the time I just walked you through my jittery templates, and so I already assumed some SBT knowledge. This time I wanted to make a full-blown SBT tutorial from scratch, but A, honestly guys, I just don't have the time, and B, over the years SBT and its documentation have improved substantially, so I'm asking you please have another look at the docs. In fact, I've taken a look myself and I realized that a couple of sections in there are very complicated. I had to go through them several times to finally get them, and honestly I still don't feel super comfortable about a couple of things. Some corners are really weird, and so this video is based on my hunch that you, same as me, find these couple of sections very complicated, and so we're going to go through them together. The sections I'm referring to are about this whole graph thing and the tasks and the settings and the scopes, and oh my god, what is all of that stuff? I just wanted SBT to compile my code. Alright, I hope that we're on the same page here. You already know a little bit of SBT. It's a build tool. You can do many cool things with it. It's recursive. You define your build definitions in .sbt files or sometimes .scala files. It's essentially a Scala dialect. It has a shell and so on and so on and so on. Let's begin. As in most of my videos, I'm on Windows and I'm using WSO2, which currently runs Ubuntu 20.04. I'm also using Windows shortcuts for the Windows Virtual Desktop feature, so at any point in time I can go back to Windows like this and then go back to Ubuntu like that. By default, if you have an empty directory and you just throw a .scala file in there with a hello world, then you just do sbt run and it runs it for you, no configuration required. Let's actually do this real quick. So I'm in my dev directory, which is currently completely empty. I'm going to take a playground 1 and I'm going to echo something into main.scala. What am I going to echo in there? Well, it's going to be simply an object, main extends app like this, and we're just going to have a print line hello world in there. Okay, so if we look in there, it's a very simple Scala program. So now we're going to do sbt run, and it should take about 10 seconds for sbt to start, compile the code, and actually run it for us. I'm sure that you already knew all that, so today we're going beyond simple convention over configuration. We're going to learn about changing the defaults, about configuring the build, etc., etc. As you might know, we might have multiple build files, but for now we're going to just create just one, right? And it's going to be a very, very simple build, so Vim is going to be enough for now. It doesn't have to be called build, but it has to have the .sbt extension, and you can have multiple files with a .sbt extension. Now, inside of the build file, you can have several projects. This is usually called a multi-build. However, this is where SBT sort of has to balance being advanced build tool and being beginner friendly. So by default, you can just throw stuff in there, which is not something that we're going to do. We're going to define a project. I'm going to say lazy val, which is a convention. We're going to call it somehow. It's going to be project A. Okay. Now, obviously, there is a way to set the name for your project. However, if you don't do that, then project A will be taken as a name. Also, since we're not specifying where it is, we're not specifying that the file should be in the dot, which is the root directory. And this is how SBT will look at this project as something else, as not as the root project. We're going to see this in just a second. So for now, I'm just simply going to say project, and I'm going to save the file. I'm going to open another panel over here, and I'm going to go into SBT right away. And if I list the projects by simply typing projects, you're going to see that this is already a second project. If you wanted it to be the same project, you would need to make sure that you're doing something like this, .in, and you pass in the file, and the file needs to be the dot like this. Okay, as soon as SBT sees this, and we need to reload over here, and if we type in projects, you're going to see that it sees only one now. but this is not something that we're going to do. In fact, we're going to get there at some point. I'm going to comment this out for now like this. Now, if I type in projects, SBT will notice that the build changed, and it will warn me that I can either disable this warning, or I can actually copy paste this thing, which is what I'm going to do. And it does global / onChange build source. And by the end of this video, you're going to know exactly what global is. Okay, so I can simply paste this over here. And so now every time, well, this last time I have to reload the project, right? But now every time we're going to change the build, we can just simply run any command in SBT. It will notice that the build changed. It will reload the project for us, which is really convenient. Let's demonstrate that. So I'm going to do projects. I'm going to see 2 projects. I'm going to do this. I'm going to run projects again. It's going to notice that the build changed. It reloads the SBT, and now we see only 1. Okay, so I'm going to comment it out again, run. We don't need to reload. We can just run projects. It will reload it for us. Now, a project has settings, and as an example of a setting that a project has is the name. So we just do settings like this, and we put the name inside. We're doing : equals, and we're going to go through the syntax a little bit more in depth a bit later. Okay, so I'm simply going to say not a, like this. I can reload, and I can do name. Right before the name was project A, we actually saw it in the prompt. Now we're seeing not a, as we see it over here in the prompt as well. Okay, now this is a setting, and by default, if you just type the name of the setting like this, it will actually show its value. Later, we're going to talk about the tasks, and for task, we'll be forced to do show name if we wanted to see the value. Otherwise, the task simply is going to run and perform its side effect. The majority of this video is about scope, so I would like to point out right away that what we did over here is actually something like project A / name. Okay, now this thing is actually not going to work because, again, this is where SBT needs to find a balance between being a very advanced build tool and being beginner friendly. Everything that you put in like this, not inside of the settings, is going to be assigned to the root project, even though we're saying project A / name. That's not how SBT works. So essentially, what I'm recommending you, even if you have only one project, even if you have only the root project, always specify the settings inside of the settings method. There are obviously exceptions to this, but we're going to get to that. For now, I'm going to comment this out, and I'm going to leave it over there, and I'm simply going to use it as sort of like a blackboard. I'm simply going to spell out a couple of things that we're going to specify over here in a short, let's call it relative syntax. Now, inside of those projects are the so-called configurations. Now, the word configuration is actually kind of ambiguous, but this is how SBT calls them, and so we're going to stick to that. Now, what is a configuration? A configuration is a bit of an advanced complexity. In my opinion, we shouldn't need configurations. In a basic build tool, you would not need them. But for now, a configuration is essentially a slimmed down version of a project. A configuration can have its source code, and it can have its own dependencies. For example, in a basic build tool, if you wanted to add tasks to your project, you would simply create another project. You would call it my project -task, and it would have the dependency on your real project. It would have its own sources, it would have its own dependencies, and you would never publish it because, well, let's be honest, nobody wants to download your tests. This is, for example, what Bloop does every time you export the SBT build. In a potentially unnecessarily advanced tool like SBT, you could do this as well. You could create a my project -task that would have a dependency on your project, but you don't need to because you can use configurations for that. By default, there are 6 configurations and they have dependencies between them, and you can even define your own. By the end of this video, I'm going to list the configurations that are built into SBT. For now, only 2 out of these 6 configurations are the ones that you should care about. It's the compile configuration and the test configuration. And for obvious reasons, the test configuration depends on the compile configuration. In reality, there is even one configuration in between called runtime, but we don't need to worry about it right now. To be honest, I don't really understand why we need this extra complexity. I have a theory though. If you have a project A that depends on project B, it basically can see its dependencies. However, it doesn't see its settings. And so this is what you can use the configurations for, so that you can have multiple configurations per project and they can share the settings of a project. Again, as a reminder, the majority of this video is going to be about scopes, and we already learned about our first scope axis, which is the project. Configurations are the second scope axis. For example, when we did name or show name, what we actually did was project A / name. So we see the first scope, but we could also do something like project A / compile / name. Now, obviously, the compile configuration doesn't have a name. However, there is a delicate fallback strategy for the settings and tasks, and so the compile slash name simply defaults, simply falls back to project A slash name. And I'm going to show you how to actually see this a bit later. For now, we're going to play with compile source directory. So if we simply do either compile slash source directory, we never need to say project A slash compile slash source directory because we are already in project A over here. Okay, so if we just type this in, we're going to see that the source directory is actually main. Now, obviously, it's inside of source and so on. Okay, if we do the same thing for test, right, we're going to see that it's test. Okay, so if we wanted to change it, we could simply do this. So first of all, let's press enter over here. Let's go over here and do this as well. Let's put a comma over here. Okay, and so now we can do compile slash source directory like this, colon equals, and there is a convenience method called file, as we have already seen on the line 7, and we can simply say something like prod. By the way, this needs to have an absolute path, so for now we're sort of ruining it, but this is not the purpose of this video. Okay, so I'm just simply going to do this, and I'm going to do that, and I'm going to do test over here. I'm going to find P, and I'm going to do unit over here. And by the way, this is exactly the same as saying new java.io.file like this. All right, so if we look at them again, test source directory is going to be unit and compile source directory is going to be prod. Now, it turns out that the project itself can also have a source directory, right? So every time we do this, it's the same as saying project A slash source directory. So we can change this as well. Okay, so if we go over here and we do something like source directory, and we're going to say that this is going to be a file, and let's just throw it into, for example, temp slash src. Okay, like this. Now, for now, I'm going to comment out these two things like this, and we're going to ask for the source directory, and we're going to see that it's in temp slash source. And if we do compile slash source directory, we're going to see temp slash source slash main, which means that there is something in SBT that actually knows that we changed the source directory, and so it actually uses it, which means if I do this, right, so if I comment them back in, we're not using it, and SBT, since, I don't know, SBT 1.4 or something, actually started warning about this, that you have a setting that you're actually not using. So let's actually go and use it. So what we're going to do is we're going to go over here and we're going to say source directory, and we're going to get its value, and we're going to have a detailed discussion about exactly what this means. And we're simply going to do slash, right, because it's a file and there's a DSL to concatenate files, and we can simply say prod. Okay, so now over here, we're simply going to do a similar thing. We're going to do source directory dot value slash unit. Right? Just because we can. And now if we reload the SBT build, it is not going to warn us because we're actually using this setting. Okay, so we have this and we have test source directory. There we go. And at this point, we might as well set the base directory because as of right now, the base directory is set to this. So let's go over here and we're going to do base directory, and it's going to be a file, and the file is going to be slash tmp like this. And now over here in source directory, we're actually going to go and use it. We're going to say base directory dot value, very important, do not forget the value, slash src like this. Okay, so we have the base directory of the project, we have the source directory, let's see, base directory, we have the source directory, we have the compile source directory, and we have the test slash source directory. All right, and now we finally arrived at this special syntax over here. It turns out that all this syntax is doing is setting the base directory. Okay, so we can also do a slash tmp. In fact, it actually has a convenient assertions for us to make sure that we're actually inside of this current project. As you can see, assertion failed, directory slash tmp is not contained in build root. Okay, so for now, let's, because we're just having fun, let's just do this so that it shuts up. All right, so now we can do base directory. It's going to be tmp. We're going to have the source directory. It's going to be tmp slash source. And we're going to have compile slash source directory like this. And as a reminder, like all of this stuff is actually project A slash compile slash source directory. In fact, as we're going to learn a bit later, it is actually compile 0 slash source directory, but we're going to talk about this in just a second. Cool. So even though there is already a bit of unnecessary complexity, everything is kind of straightforward for now, right? We have one build file or potentially multiple build files. Inside of it, we have a project or multiple projects, and every project can have multiple configurations. Projects can have their own settings. Configurations can also have their own settings. Now, SBT is a tool, and so it can run tasks for you. You type something in, and it runs the task. Even though the classic examples for tasks are things like compile, test, and run, since their names collide with configurations, we're going to run with the console task. And so tasks are our third and last scope axis. By the way, the configurations always start with a capital letter, and the tasks always start with a small letter. Everything is in camel case. So to recap, we have a build file with a bunch of projects. The projects have configurations, the configurations have tasks, and all of them can have their own settings. Projects can have settings, configurations can have settings, tasks can have settings, and even settings can have settings. I know it's a little bit confusing. Stay with me. A classic example for task scoped settings is something like linting options, whereas it's very common to have something like fatal warnings for, well, pretty much the entire project. You might want to go into compile/console and remove fatal warnings from there. Let's start by typing something like compile/console/scala C options like this. And as a reminder, this is the same thing as same project A/compile/console/scala C options. And we're not going to see anything, but something happened. So for the first time, if we run inspect, exactly the same thing, right? So we're just going to do this, and we're going to do inspect, okay? Then if we scroll up, then we're going to see that this is actually a task over here, right? Not a setting. And we see the type of the task. It is a sequence of strings, right? We already know that, right? Scala C options are just a bunch of strings, okay? So if you wanted to see the value of the task, we would need to use show, okay? Instead of inspect, we would use show. And by the way, since we're talking about inspect already, there's also inspect tree, which displays the entire tree like this. In this case, the tree is very, very simple. However, if you go for something like compile/compile, the tree is going to be gigantic. Let me scroll up a little bit. As you can see, there's a lot of stuff in there. You can inspect it at your own pace. All right, let's go back to showing this, and we see an asterisk over here, right? So because it's a sequence, this is how SBT displays sequences. It's sort of like a markdown list, right, with the asterisk, or I'm used to calling them stars, so I'm just going to say star. All right, so let's go and play with it. So we're just going to go over here, and we're going to do compile / and we're going to do console, and we're going to do Scala C options, and we're going to do sequence, and we're going to pass in we're going to do hyphen language, and this will enable all of the language features. Okay, so now if we go over here and we're going to do this, we should see at least the language, right? It's only one, which is why we see like only one star. If we had like two things in there, we would see them under each other. It's like a markdown list. It is very important to understand that all of these scopes are sort of optional. And when I say optional, I don't mean that you can leave them out. I mean that they sort of feel like an option. For example, if you didn't specify console, something would put in something like a none, right? We have seen this already, this magic value, which was called 0. So we will see now that this value is actually different, right? So this is not what I meant by optional. Also, you have some very special scopes like this build, so you can do something like this build / Scala C options, but this one is a bit limiting, and we're going to talk about it by the end of the video. What is also important to understand, and we're going to talk about this in detail by the end of the video, is that there is a fallback strategy. So if we go over here and we replace compile, oops, this is not what I wanted to do. We're going to replace compile with test. We're going to see that the value is not there, right? Even though for compile, why is it not there? Oh, I forgot that we have the 0. Okay, hold on. So compile console, we have this. And for task console, we actually don't see this, even though the task configuration actually depends on the compile configuration. And this happens because if we inspect this, this might not be super visible, but if you go over here, okay, it says delegates, right? And this is essentially the entire fallback strategy, and it's already ordered. So first it's going to look here, then it's going to look here, then it's going to look here, and so on. And it turns out that in some of them are already defined before it arrives over here. This means that somewhere in between, right? So somewhere like over here is already specified somewhere, and it is specified somewhere over here. So if you were to jump into some of them, you would actually see one of them that is specified. from here, you don't actually see which one it is. It could be this one, or it could be this one, for example. So if you were to interrupt this chain by specifying, for example, compile / scala C options, maybe it would actually work out for us. Let's actually go and try this. So we're going to go over here, and we're simply going to go, we can either remove this or we can say 0 over here. Okay, so let's hope that I'm right, and we're going to show this, and now it is set, right? So we're showing the task / console, it fell back to one of these guys, and it actually found it. Okay, we can also remove the 0 entirely like this. It should have exactly the same effect. Okay, so now task console scala C options and console / console scala C options. I was hoping that they would have exactly the same thing, but they don't somehow. Let me actually revert this to this like that, because I wanted to have an example for project settings, an example for configuration settings, an example for task settings. Oh, that's why, because I'm typing it wrong. That's why. This should be compile / console scala C options, right? Yeah, this makes way more sense. All right, so if we have this, then this one should show the language, and this one should show the language. Yeah, that makes way more sense. All right, cool. So let me do this like this, and now the task is not going to have it, but the compile console is going to have it. Cool, so now that we know what scopes are, let's dig a bit into something else. So I'm going to go, and we're still not done with this project, but I'm going to go over here, and I'm going to use my Jitterate template to go and create another project, because I want to open VS Code and show you something. So I'm going to call it, yeah, so we already have playground, so let's call it playground 2 like this. Okay, so I'm simply going to open it like this. And we're also going to import the build when Metals wakes up. However, as of right now, actually, I want to show you something completely different, but we can already open the build file. And when Metals wakes up, we're going to import the build. And for now, actually, what I wanted to show you is, come on, let me press escape. I want it to go away. Show logs. It's the opposite of what I wanted. Doesn't really matter. Okay, so what I wanted to show you is that if you actually open the settings in VS Code, and I'm simply using VS Code as an example, okay, that's not what I wanted. I wanted to have, that's not what I wanted. I wanted to do this, JSON. Okay, there we go. So as you can see, I was already experimenting with this. So if you just go and type into something that has settings, something like foo equals 1337, it will tell you that it doesn't know what this configuration is. And by the way, props to VS Code for using the words configuration and settings in the same phrase. Well done. Now, I'm bringing this up because in SBT, there's kind of a difference between something having a setting and something using a setting. As we have seen before, we were setting the source directory :equals /temp or something, but we were not using it in any of our other settings. So let's dig into this a little bit more. SBT is a graph-based tool. Every node of the graph is a setting, and every directed edge is a dependency on some other setting. This usually means that this other setting needs to be evaluated before this one. The entire graph is stored in a map where the keys are the settings keys and the values are the settings values. The way I imagine it in my head is that the keys are actually strings where you take all of the scopes, simply concatenate them together and throw them in. So for example, if we go over here and I'm going to do something like, let's say that it's like project A / compile / console / scala C options, right? So let's say this is one of the keys, and another one would be the one where you don't specify the configuration. So this one is going to be 0, like this, right? And so even though they look the same, and even though they feel as if there is some sort of hierarchical relationship between them, there's actually none. They're completely different keys. We're going to talk in a second about the distinction between settings and tasks, but in terms of the type system, they actually extend the same thing. And so sometimes you can do kind of silly things by doing something like show project A / compile / scala C options, right? Because the third scope is a task. It actually can also have settings, right? So you can do scala C options / scala C options like this. Actually, this is a bad example because scala C options is actually a task. What I wanted to show you was something like a source directory, right? Source directory is a setting, so it can also have settings, right? And you can sort of like mix and match them, even though this doesn't actually make sense. We have seen before that we actually even managed to put something like blah over here, and somehow it worked. Well, actually, it was not blah. It was actually console, and I wasn't even aware that the console configuration exists. All right, so we got the keys, and those keys are sort of like not even on the graph. If you kind of picture a graph, imagine that on the side there's sort of like a legend, and all the keys are simply listed there, so they're not even on the graph itself. The graph contains the settings or tasks, not the keys. But let's talk about the keys first. SBT comes with a bunch of built-in keys, but there's nothing special about them. You can define your own and they will look exactly the same. If you're configuring your project by using .sbt files instead of .scala files, then an object called keys _, is automatically imported for you. And so at any point in time, you can do something like keys dot, and you can use auto completion if you use metals to see all of these settings. For example, before this, we were playing around with source directory like this. Directory, right? And we see that this is a setting key that returns a file, and you can even jump in there, and we're gonna end up in the object keys, and as you can see, it's bunch of keys, and there are two factory methods for them. Actually, there are three, but that's not the point. There's a setting key which has the value that is going to be returned, and there is always the description in parens. Okay, so for example, the one that we were playing around with was the source directory over here. As we can see, it's just a setting key with a file. It has some description. It also has some rank, but we don't really care about the rank. So there are three kinds of keys, but they all extend the same thing, which is something that I already mentioned, right? So there is the setting key, and there's also the task key over here, right? And there is also the input task key, and the difference between them is actually very simple. The settings keys, they're sort of like vals. They're instantiated only once, and they're loaded when the build loads, right? So pretty much when you start SBT. And tasks are more like defs. They're evaluated every time. Input tasks are simply tasks that can have parameters. For example, the run task can have parameters that will be passed on to the main method. Run main is also a task that has a parameter, which is the main that should be run, and a bunch of other parameters that will be passed to the main as arguments. It is very important to understand that this sort of concept of timing is not defined on the settings or tasks. It is defined by their keys. When you have a large SBT build, it will take some time to resolve all the settings. Remember, all of them have to be loaded when SBT boots up. For example, at work, we have a very large multi-build project, and it has like more than 100,000 keys. In fact, if you have more than 100,000 keys that need to be resolved, SBT will actually print it out for you. It takes about 25 seconds to resolve all of them. Obviously, it can be optimized, but nobody has time. This is one thing that people don't like about SBT because it keeps the entire build in memory, right? It has to load all of these settings every time you start SBT. So if you're hopping between projects, SBT is probably not for you. There is also a tool recently released called SBTN, which kind of connects to the SBT server, but I haven't played with it. I'm very happy with Bloop because Bloop keeps its build on the disk, which is also why you have to re-import the build all the time so that it creates the build on disk with its JSON files and whatnot. And so every time I switch between projects, it's sort of like it's already loaded. It just needs to read it from disk, and everybody has an SSD these days.